Really sorry I couldn't be there today. My son is not feeling too well, and I'm gonna be home for the morning. If you need me, you can come see me tomorrow morning. I should be back Thursday morning, um, and I'll also be there during enrichment. So if you need me, you can always come up. I'm in Miss Bradley's room on the second floor. We're in the science section, right in the middle. So if you need to have any questions about something, come ask me there. Um, so I want to start off and see what we remember. We talked a little bit about GCF yesterday. We talked about it when we were working on problems. So what I want you to kind of do is just do a little bit of practice as we walk through this one. I've only given you two different factors today. So go ahead and if you'll pause the video, try these three on your desk. Don't forget to grab the markers and the erasers first. All right, so let's take a look at how to use. I'm going to do them with the factor tree method like we talked about yesterday. It seems to be the easiest one. We can do ladder method, and I'll do that with the middle one if you like, so you can kind of see. So if I do the factor tree method, I'm going to come down 2 and 17. I know my divisibility rules from a while. It's not even, but 5 plus 1 adds up to 6, so it's divisible by 3. And when I divide it by 3, I get 17. So my GCF in this case is 17. Okay, moving on to the next one. So if we take a look at this one, if I'm going to do the ladder method, 45. Well, I'll just shortcut this. I'll put a ladder around this one and give it a shot. I'm going to put my ladder around this one over here and say, okay, it's divisible by 3. So that gives me 15. If I divide 75 by 3, I get 25. Then I can see, okay, they're both end in 5, so they're both divisible by 5. So I'm left with 3 and 5. These two are both prime numbers. Both 3 and 5 are prime, so I know I'm finished. And then to find the GCF, I multiply these two numbers together, so I get 15. All right, my next problem is this last one. This one's a little more challenging. I kind of had a little fun with it. I picked some big numbers to have you guys practice. I'm going to look at this one and go, okay, well, I'm going to start with the smaller numbers, the one I know. 121, remember our fluency quiz, that's actually 11 times 11. Those are both prime, so we know that that's the end of it. Let's just do a little bit of check and see if this one is also prime. Okay, let's see if this one also divides by 11. So come over here and say 187. I'm going to do it up here, do all the work. 11. 11 goes into ones. Subtract, I get 7 and 7 left over. So yep, it goes into it 17 times. Again, I'm down to all my prime numbers. 11's prime. Oh, I didn't mean to erase. 11 is prime. 17 is prime. We can see what they have in common is 11. That makes my GCF 11, 15, and 17. All right. Now we're going to go ahead and take a look at multiplying fractions. All right, so let's take a look at what we're going to do today. We're going to multiply fractions. And just a heads up, after you finish this video and the lesson, you're going to go ahead and work on the packet review quiz. I've set up for about 45 minutes for you guys to work on that today. All right, so let's take a look at how to multiply fractions. Our goal by the end of the day is to be able to multiply fractions by whole numbers and fractions by fractions. Again, this should be a review from your previous years, probably 4th and 5th grade. Let's take a kind of look at it. So how do we do this? The first thing we do, as you can kind of see, we're going to write down all fractions or all whole numbers as fractions. That's the key to it. Anytime we do it, you can see right here, we write any fraction is 5 over 1. Okay, that's the key. And then we're going to multiply fractions just like we practiced yesterday, or as we know how to do. When we multiply straight across. 5 times 3, 4 times 1, and then we can simplify down to our mixed number. We do the same thing if we're doing fraction by fraction. And here's the kind of neat thing about fractions. If you look at it, it goes, okay, if I've got these pieces right here, I'm always going to find a fraction multiplied by a fraction is probably going to get us a smaller fraction because it always takes that thing out. Okay, so you can kind of see the key again is just multiplying numerators by denominator and multiplying denominators. Again, I kind of go back to the idea of I like to think I multiply like terms. My numerators are alike because they're on top. My denominators are alike, so they're on the bottom. It kind of helps us build some ideas for what we're going to do later on in pre-algebra and algebra, because a lot of it does come down to the idea of like terms and working with them together. Okay, so now that we've kind of reviewed how to multiply them both, Let's actually do it. So we'll start with that first one on top. We're going to multiply 2 over 1 times 2/5. So we've got 2 over 1. That's our first goal, is to do that. Again, I don't like the x, but you're welcome to write it, times 2 over 5. So again, we're going to multiply straight across. I end up getting 4 times 5. 4 over 5 is my final answer. I can't simplify that any further because, of course, we've got the idea of that same prime number we were talking about back in our GCF conversation and come up with the answer. Okay, go ahead and pause the video and try this next problem. All right, guys, so let's take a look at this one. It's the same setup. So you'd set it up as 3 over 1 times 1 over 5. Now here's the really cool thing. I don't know if you guys remember about this. There's an amazing step called cross reduce. It's kind of the idea that if I've got numbers in common that are across the x, I'm going to put that x back in just for a second, that follow that line, I can cancel them before I multiply. It allows me to multiply with smaller numbers instead of having to work with the largest number set. So I actually could cross out 1 over 1. It's not going to change the value. Again, it's the identity number. It's kind of like the idea of saying, okay, if I rewrote this problem, I could say it's the same as 3 times 1 over 1 times 5. Then I can reorganize it and go, okay, well, I know multiplication is commutative. So I could say it's 3 times 1 over 5 times 1. And you'll notice right here, that's just what? That's 1. 1 over 1. With 1 over 1, we know the answer is simply going to be whatever you started with, that identity property multiplication. So the final answer is 3/5. It's a neat idea to think about. And we'll delve into that as we continue to explore all this, why this stuff works and how it's a great idea to it. Let's try the next one. Ooh, everybody's favorite word problems. The sloth spends 4/5 of its life asleep. Now, I'm all for that. Lots and lots of rest. If the sloth lives to be 28 years old, my goodness, how many years does it spend asleep? So we can kind of set this same problem up. We've got our fraction. We've got our whole number. So kind of keep in mind, we've got the curve. We circle all of our words. We underline our labels. We go and box our labels, and we underline our question. Now we're going to set up the evaluation. 28 over 1 times 4 over 5. Now there's no cross reducing on this one. You can see 4 and 5, 1 don't share any common factors, 5 and 28 don't share any common factors, so I'm going to have larger math problems. So 8 times 4 is 32. I'm going to carry my 2. Or carry my 3, I should say. 4 times 2 is 8, plus 3 is 112 over 5. Now we're going to simplify that one step further. 112 divided by 5. I say it goes into it twice. 12 left over. I think 5 goes into 12 twice again. This time with 2 left over. So my final answer is 22 and 5. Sorry, not 5. 22 and 2/5. And then I'm still not right until I put the label years. All right. Go ahead and pause the video. Find out about our little brown bat. How long is it going to sleep if it sleeps for 5/6 of its entire life? Again, how do we get this life? We only sleep for like 8 hours a day. That's like 1/3 of our life. These guys sleep forever. All right, so same problem setup. We're going to go ahead and circle any of our numbers that we have, box any of our words, and underline our question statement. Okay, so now we've got our idea. All right, so 24 over 1 times 5 over 6. Oh, again, I can cross reduce. These two right here share a common factor, so I can reduce them first, saying, okay, 24 divided by 6, their GCF is 4. 6 divided by 6 is 1. It's going to save me some time in my math. 4 times 5 is 20 over 1. Got one little bit more to simplify, and they actually sleep for 20 years of their life. That's a long time. All right, let's take a look at fraction times fraction now. So again, we're not going to do a lot of these just basic problems. I want you to look and focus our time on word problems. So Frank has half the lawn left to mow. On Saturday, he mowed 2/3 of what he had left. What fraction does Frank have left to mow on Saturday? Okay. Sorry, what fraction did Frank mow on Saturday? So again, let's do our work. We circle our fractions, our numbers, box any of our words, okay, and underline the question statement. How much of the entire lawn? So we know he had a half left to mow, so 1/2 times 2/3. So he mowed 2/3 of it, and it's going to let us figure out a problem. So again, straight across, 2 over 6, or you can cross reduce saying 1/2 times 2/3. You can go, okay, these both divide by 2, so they make them 1. So 1 times 1 is 1. 1 times 3 is 3. Either way, you see, no matter how we go, we either simplify here by 2 or we simplify here by 2. You're both doing the same steps, it's just where you're doing it. The answer is not 1/3, but 1/3 of the lawn. And I'm not as bad if you don't want to say left to mow 1/3 of the lawn. He mowed. Okay, that's he only mowed 1/3 of his lawn. All right, it's the one for you to try. Figure out what fraction of the total beads did she use to make her necklace. Go ahead and pause the video and see what you guys come up with. All right, so I'm going to circle my things again. 1/2 and 2/5. We know that the key is beads or remaining beads, so we're going to box that. And then we're going to underline what fraction of the total beads did she have left. Okay? Did she use to make the bracelet? So if she used half her beads to make a necklace, what fraction did she use to make the necklace? So, or the bracelet. So how much does she have left? If she used half already, how much does she have left? She has half her beads. Okay? So she had half remaining because she already used the first half here. It happens to be an equivalent fraction, so we don't have to come over and go, okay, 2 over 2 minus 1/2. We know that half of 1/2 is half. Times 2/5. Again, I can cross reduce. I can divide by 2 here. 2 divided by 2 is 1. 2 over here divided by 2. And I have 1/5 of her total beads to make the necklace. Don't forget, you can see I'm boxing all my answers. So now that you've kind of taken a look at that, go ahead and make up your own problem. Trade with a person next to you to solve it. If you don't have a partner to share, you can solve it when you're finished. And then you guys are going to take your practice packet quiz. You got 45 minutes to take that packet quiz, not practice packet quiz, packet quiz. When you're finished, you can start the 12 problems you have in your homework, and they're due Friday. All right, if you have questions, come see me tomorrow or again in enrichment, and I'll be happy to help you all.